Hello guys, welcome back to the channel. This is Trockers. Okay, we want to go over a trigonometric equation from Cambridge 2023. Okay, the question reads, solve the equation sec squared theta plus 5 tan squared theta equal to 9 plus 17 sec theta for a range of values from 0 degrees to 360 degrees. It's allocated 5 points. All right, guys. So remember, for every question, we need to make some annotations. Here, it's given in terms of sec, right? And it also has tan. So you need to think about the relationship that connects tan and sec. All right. So I don't want you to memorize these things, but I want you to know from the basics. Remember, we know that sine squared theta plus cos squared theta is equal to 1. Right. So from here, we know that sec is 1 over cos. So if I divide everything by cos squared here, by cos squared, right, I'll have tan squared theta plus 1 equal to sec squared theta. So I can replace this with sec squared theta minus 1. So that's how we can remember this. Okay, with that being said, guys, let's go ahead and get started. All right, so we need our whiteboard here. All right, so allow me to rewrite this question down first. So the question is, okay, let me use this one. The question is sec squared theta plus 5 tan squared theta equal to 9 plus 17 sec theta. All right, so from this stage, we can go ahead and replace this with, remember, it's sec squared theta minus 1 equal to 9 plus 17 sec theta, right? So from there, we can go ahead and simplify. So we have sec squared theta plus 5, sec squared theta minus 5 minus 9 minus 17 sec theta equal to 0. We have to bring all functions to one side, right? So we have 6 sec squared theta, then here minus 17 sec theta. This becomes what? All right, this becomes minus 5 minus 9, that's negative 14, minus 14 equal to 0. Right. So from here, if you want, you can let sec theta be equal to x, then you create a quadratic in x, or you can get rid of sec squared at this point. So that you have cos. So I can rewrite this as 6 over cos squared theta minus 17 over cos squared theta minus 14 equal to 17 over cos theta here, sorry, right? Then I can multiply both sides by cos squared theta, so that I will have 6 minus 17 cos theta minus 14 cos squared theta equal to 0. And this, when after dividing by negative 1, you should get 14 cos squared theta minus 17 cos theta plus sorry, I'm dividing by plus, then here it's minus, right? Oh, I'm sorry. Okay. Here it's minus, I want this. All right, so minus 6 here, right? Okay, so I can remove this. Okay, cos theta minus 6 equal to 0, right? Then we have, now we can solve. Let's see if we can factor this problem, or if you want, you can let cos theta be equal to x, so that you have 14x squared plus 17x minus 6 equal to 0, right? So now let's see if I multiply 14 and 6, 14 times 6, 14 times 6, I have 84. Do I have factors of 84 that sum to 17? Or let's just go ahead and use the quadratic formula. So x is equal to minus b plus or minus square root of b squared minus 4 times this times that all over 2 times that. So my x here equal to negative 17 plus or minus over 28. If I simplify that, I'll get 17 squared minus 4 times 14 times negative 6. I'll have 625. Okay, so we had those factors, right? So now it's 17 should be 25 over 28 square root of answer. Okay, so now if I'm going to get negative 17, okay, negative 17 plus 25, okay, negative 17 plus 25 divided by 28. Okay, so I have 8 over 28, or negative 17 minus 25, divide that, so I have negative 42 over 28, right? But remember cos theta, right? So cos theta was equal to that. So cos theta was equal to x, so it's equal to 8 over 28, or cos theta equal to negative 42 over 28. Here we don't have solutions because it's more than negative 1. All right, so go ahead and solve from here. So theta is equal to arc cos of 8 over 28, right? So if I find arc cos of 8, make sure your calculator is in degrees, divided by 28, I'm getting 73.398, right? But this is cosine, guys. So all students take calculus. Cos is also here, it's theta, right? And here in the fourth quadrant, it's 360 minus theta. So since this is cos, it's going to be 360 minus that. So when I say 360 minus 73.398, therefore theta is equal to 73.4 degrees, or if I say that, I'll get 286.6 degrees, right? So if it's a Cambridge problem, make sure you approximate your answers to 1 decimal place, but for ZIMSEC, you should estimate to the nearest degree, which is 73 and 287 degrees, right? So guys, if we come back here, okay, so if we come back here, remember our solution was this. We started off with a function in sec squared. Then we used that identity. It was very important. Then from there we simplified. You could have solved this in terms of sec squared, but remember at the end you have to invert your solutions, or you just change here like what I did. Then from there you simplify. You convert this trig equation into a what? Into a quadratic, because it was just a disguised quadratic equation. Use any method there to solve, then you get your value of x. Remember to go back to theta, then from there you find your principal solutions, as long as they are within the range from 0 to 360 degrees. With that being said, guys, I'm signing out. Take care.